These are notes on adding error bars to your graphs. So we've already discussed in class why we add error bars and the significance of them, so I'm not going to go into that here. But here's all my data that I collected in class. Remember, I just collected on stomata and specific leaf weight. You guys also collected on surface area. And then I have the lower and the upper. And you can tell I probably have some outliers in here, like if you go down here, these two are probably outliers. And if you're thinking you have outliers in your data, you really need to recalculate. Perhaps you calculated incorrectly, perhaps you got an incorrect mass or an incorrect surface area. I'm more than happy to help you check your calculations, but please do not put in an analysis of error that you calculated incorrectly. It turns out because I have so many trials, I have 40 trials at the least, because these two don't count as trials, so here 42 minus 2 is 40. Having one or two outliers actually isn't going to affect my data too much as far as my averages. As far as your data, if you only have 4 or 5 trials, outliers could significantly affect it. So to get my graphs, first I want to get the average for each one. So I'm going to put in lower, upper, lower, upper, and that's right, yeah, yes, okay. And so now I'm going to get the average. So to get the average, anytime I want a formula, I'm going to press equals, and then I'm going to start typing the formula. So AV, and notice right here is average, so I double click on that, and then I can highlight the cells I want to average. So I want to average everything from here down to here. If I go a little over, that's okay, I can just bring it up. And then I close my parentheses and I hit enter. And there's my average for that entire column. So even see like a 7.7 here really didn't affect this average much when you kind of glance through all of these numbers. And that 7.7, maybe it's an error, maybe it's not. When it comes to counting stomata, I'm not as concerned about people making errors as when it comes to calculating things. And so then, in order to get the other averages, instead of typing that in each time, I can take this little square here and drag my formula over, and that gives me my averages. Now, here, these two, I have the exact same numbers, so that formula is going to be pretty good. But here, if I double click, you'll notice this bar, or this blue box doesn't go all the way around my data, so I need just to drag this box down, press enter, and now it's my average. And the same thing here. I'm going to fix that up a little. All right, so now I'm going to show you how to make the graphs. You should already know how to make the graphs, but so if you do, you can kind of fast forward this a little. If you don't, obviously you're going to want to pay attention. So I'm going to do 2 separate graphs because these numbers, these averages are so wildly different, it doesn't make sense to put them on the same scale. So I'm going to highlight what I want here, and go to insert a column graph, click there. I can get rid of my legend there because I really don't have much else to go on. And then if I go to layout, I can now add my titles and my axis labels. So I'm going to put a title in here, and this is stomata density for upper and lower leaves. And then I can put in some axis titles. My horizontal axis, I'm going to say location on tree. And then for my vertical axis, I'm going to say, oh wait a minute, I don't like that kind of vertical axis. I want one that's rotated. There we go. I'm going to say stomata density, and the unit was like stomata per, and I don't remember the exact field of view. I talked about it in class, but now I'm at home. I think it was like 0.04 millimeters, something like that. Whatever I told you in class. So that's my unit there. And so now I can go ahead and I can do that for my other data. Okay, so now I have both my graphs here, and you can see this is why I chose the scales I did, right? So Actually, I think I'm going to change this scale here. So if I go to axis, I believe it's on vertical axis, go to more options, and I want to change this scale. I want to make this cross at 0. That didn't do anything. And let me try that again. Format axis. Oh, here, I want to make my minimum fixed at 0. 0.0. There we go. All right. So now this shows me starting at 0 rather than starting at 19, because starting at 19 maximizes the change, where starting at 0 minimizes it, but I think also gives us a little bit better of an understanding. You'll notice when we had that before, if I go to Control Z, look, it looks like there's a huge change, but when we put the axis at 0, then it's a much smaller change. Okay, so now I need to go ahead and figure out my standard error to get my error bars. So the first thing I need to do, I'm going to go back over here to where I was doing equations. I need to do the standard deviation. And the standard deviation shows the spread of numbers. So, for example, if I give a test and the average is 50, and everybody falls between 40 and 60, that's a different standard deviation than if everybody falls between 0 and 100. So, the smaller the standard deviation with respect to the average, the closer bunched together your numbers are. And so for something like stomata density or specific leaf weight, that's important because we need to know, like, do we just have leaves that are all wildly different and we're coming up with this average, in which case the average doesn't say much? Or are these leaves pretty much all clustered around the same number and then the average tells us a lot? So to figure out standard deviation, it's again an equation, so I'm going to start with equals, and I do ST for standard deviation, and it's the second one here, ST dev. So I double click on that, and then same as with average, I go through and I highlight those, I close the parentheses, and there's my standard deviation. So 4.49, that's clustered pretty close together when I've got 20 here as my average. And so I'm going to drag this across. Same thing as I did before. Kind of clean up these formulas a little, make sure they're all accurately reflecting the data. And now my standard error is actually the standard deviation divided by the square root of the number of samples I have. So the more samples I have, the larger number I'm dividing by, which is the smaller the standard error. That's why the more samples you have, the more sure of your data you convey. And so let's take a look at that. So again, I'm going to say equals, and here's my standard deviation divided by the square root. So I'm going to do SQ, and it's right here, SQRT. And the square root of here, I've got 40 samples, so square root of 40, close the parentheses, that's my standard error. And again, I'm going to move this over, except here, this is out of 45, so I'm going to come up here to the formula bar, and I'm going to click 45, and I'm going to hit enter. And then this one here is out of, let's see, 45 minus 2 is 43. I'm going to say 43, and I'm going to hit enter. And so now these are my standard errors. So essentially it's saying it's this average plus or minus that much. And that's going to get most of my data. And then what we want to compare, of course, is whether these error bars overlap, because that will tell us if our differences are significant or not. And so I'll show you how we're going to put those on the graph next. All right, so the way you put in the error bars is you click on your graph and you go to Format. You go to Layout, and then here it says Error Bars. It's under Analysis in the Layout menu. If you have a different version of Excel, it might be slightly different, but believe me, it will be there. This is a pretty old version of Excel, and so please don't come to me and say, oh, I can't do error bars in my version. You can. So you click on error bars and then you go all the way down to more error bar options. You don't need to worry about anything else. So here's my error bars, and ignore whatever goes on the graph while you're formatting them. We're going to go down to custom error bars, and then we're going to specify the value. We're going to tell it, we calculated our standard error, so we can tell it what to do. So I click on that, and then I delete what's in the positive error bar value, and I'm going to highlight this. So this is my stomata density. So this and that one. And then I'm going to delete my negative error bar value, and I'm going to highlight the exact same thing. And I'm going to say OK. And that gives me my error bars. Okay? I'll do that again for this one. And again, ignore whatever's going on with the graph while I'm doing this. So, whoops. Go more error bar options. And I'm going to say custom. So again, like if you see this, don't worry, just keep going. Specify value. This time I'm going to do it from the ones for specific leaf weight. And then I'm going to delete that and do it again. And anybody who wants to know why I'm doing this twice, I can explain it in class. If you don't care, don't worry about it. Some of you can probably figure it out. Say OK and close. And then I have my error bars. And so then remember, I'm looking at areas of overlap, okay? And I should find that there really isn't any overlap. Now here on this graph, if we go back to the axis and we change this back to, I think it was at, well now it's at 17, but that's fine. And I close this. Notice now it's actually, so it's a little easier to see the error bar differences than when the axis was on 0, so you can kind of play around with that and do what you want. I can look at them here and go, okay, so there's clearly no overlap, and then if I want, I can put that back to 0, because you know it's just a different scale, so there's also going to be no overlap here either, because it's just a different scale. It's kind of up to you how you want to format that, okay? And so what we're seeing is that there is a statistically significant difference with stomata density, that there are more dense stomata on the upper leaves than on the lower leaves, and with thickness, that the upper leaves are thicker than the lower leaves. And with thickness, that's what we would expect. We would expect that where there's more sun, you're going to have thicker leaves. Also, you should have smaller leaves, so we'll see if your surface area also follows the expected trend. And you can think about why. Stomata density is interesting. Stomata density really varies by climate. So in a water-heavy climate, where getting water isn't a concern, you may find a higher stomata density in leaves that have more access to sun, because then they can open the stomata and let out water, essentially sweating, which cools the leaf down. In drier areas, you're probably going to find fewer stomata where it's really hot, because you don't want a lot of water escaping. So stomata density really does vary based on climate as well as location on the tree. And you're certainly welcome to do some more research. A lot of the stuff that's out there is ironically pretty dense. All right, have a good day, and let me know if you have any questions on this.